This will be the last video for lesson 27. We're actually going to scrap half the rest of these notes. Honestly, all I'm going to do is this example right here, okay? The idea is, this is find the power series of this. Okay, how do I find the power series of arctan? Now that it's very difficult in terms of considerations, but if we recall back to the last example that we just did with the natural log function, okay, we first said, well, what's the derivative of natural log? Well, that's 1 over x. So then let's take the integral of that particular power series. We're actually going to do the same thing, okay, nearly the same thing. So arctan, is there some relation that we have in terms of just generic arctan? Well, I know that if I look at, I think the derivative, right? If I actually do f prime of x, isn't that 1 over 1 plus x squared? I believe that's the derivative. I mean, if I take the integral of that, I get back to arctan, so that's the derivative. Well, isn't this close to that 1 over 1 minus x junk again? I mean, if I change this to be 1 over 1 minus a negative x squared, hey, look, that's the exact same form as a geometric power, okay? If it's the same as the geometric power series, let's just go ahead and use the derivative is equal to that. And I can take the integral of the power series, just like I did in the last example. Okay, so let's do that. This series is again equal to the series as, and I've got to remember it because I never remember these, n equals 0 to infinity of, and it's just x to the power of n, okay? So again, this is the geometric, it goes to this. So if I'm looking at this thing right here, this series will be equal to the sum as n equals 0 to infinity of negative x to the power of 2 to the power of n. Huh. Well, if it's negative x to the power of 2, then this is the same thing as the summation as n equals 0 to infinity of a negative 1 to the power of n. Okay. And then x to the power of 2n. Well, how do I deal with finding out what the series for arctan is? Because this isn't the series for arctan. This is the series for this thing. Well, the series of arctan would be me going back up this way, taking the integral of this thing. So let's take the integral of this thing right here. I want the integral of the summation as n equals 0 to infinity of negative 1 to the power of n, x to the power of 2n. This would be my actual arctan of x. Okay? Well, what is the integral of this thing? Well, again, this is x to the power of some number. 2n is some number at any given point. So the integral of that is going to be x to the power of what? Increase the power by 1, divide by that power. So this is equal to the summation as n equals 0 to infinity of negative 1 to the power of n, x to the power of 2n plus 1, divided by 2n plus 1. That would be my series for arctan. Now here's the real question. When does this converge? Okay? For what values of x does this converge? Well, if we're very careful about this, okay, we'll go back to this right here. This one right here. This right here is true for the absolute value of x is less than 1. So let's go to this right here. My absolute value is, my x is now a negative x squared. That's supposed to be less than 1. Well, if that's the case, then let me go ahead and solve this thing. I have x squared is less than 1, absolutely. Well, absolute value won't matter because, again, it's technically plus or minus anyways. And the x squared part, taking the square root of both sides, isn't going to change anything. So really, that's the interval again, and my radius is 1 again. Okay, so this is a convergent power series to arctan on this interval. Now, that actually covers all the notes that I really care to go over. Example number 8. This one right here is technically supposed to be in 9.8, okay? But we're not actually going to go through that. I think you get the idea with the derivatives and the integrals, okay? And you can use the previous rules to determine how convergent those things are going to be, okay? Likewise, we're going to skip 9 and 10 because 9 and 10 we're actually going to have a 9.10 section. I think it is important that we go through at least the majority of that section. So that completes lesson 27. Again, it's all about the geometric series and the geometric power series and how those things converge, when they converge, and how we can manipulate them.